the uniform distribution from A equal to 5 to B equals to 25. A says find the probability that X lies between 9 and 20. So basically, I'm going to use my definition we just did in the previous problem. Uh, and so we see my height is, or my length is 1 over B minus A. My width is, it's going to be that whoever this is C and D. I'm looking for this red area. And so we're gonna let it says X lies between 9 and 20. And so we're gonna let C be 9 and D be 20. And let's figure out what we got. Okay. Ah, excuse me. All right, so we're gonna so think about this. This is my length times width. Okay. And so we need to find the area of the probability. We're gonna so we see A is 5, B is 20. We're gonna let C be 9 and D be I'm sorry, B is 25 and D is 20. All right, and so if I want to do my length time my width, my length is going to be there 1 over B minus 8, which is 1 over 25 minus 5, 1 over 20. My width is going to be the distance between C and D, so it's going to be D minus C, which is 20 minus 9, which is 11. And so my area is going to be my length time my width, which is 11 times 1 over 20, which is, what's that, 11 over 20? What's that, 55? So 0.55. Okay, and so my probability that X lies between 9 and 20 is going to be 55, 55% of 0.55. And I'll do the same thing each time. I just change up my C and D. So next time we're going to let C be 6 and D be 20. And then my D minus C will be 20 minus 6, which is 14. And so now I have 14 times 11 over 20, times 1 over 20. Sorry. And we get 14 out of 20. Toss that to calculator to get your percentage. 14 out of 20 is going to give me 70%, or 0.7. And that's my probability, 0.7. You just continue on down. Some of the problems we missed. This is session 5.1. And I see you got partial credit for number 5. And so it says determine whether the following graph can represent a variable with a normal distribution. Explain your reasoning. If the graph appears to represent a normal distribution, estimate the mean and standard deviation. Okay, so here's our graph over here. And it's a normal bell curve. So yes, it does represent a normal distribution. So I see you have the mean correct. So the mean is going to be that center point. So that center point here, that's around 15, 16, 17. You're right, it's about 18. So 18 is my mean. So that's pretty good. And so next they want us to find, let's see. Next we're supposed to find the standard deviation. So basically, to find the standard deviation, we want to look at our uh, points of inference, or so where our graphs changes. All right, that's what we want to do. And so these are our inflection points, I'm sorry. And so my inflection points is where my graph changes. So it changes right about at the 21 mark here. And so my answers are not 21. That's where it changes. So my standard deviation is the difference from the mean to my inflection point. And so the difference between 21 and 18 is 3. So your standard deviation should be 3. Let's see what you put. So you did put 21. So good job. I identified that inflection point. You just got to subtract uh, the difference. You need to find the difference between the mean and inflection point. And so you get 3. Okay. So let's move down to number 10. I see you missed number 10. All right, so we got partial credit for this. Okay, so let's see what we can do with this. It says you work for a consumer watchdog publication and you're testing the advertising claims for a tire manufacturer. The manufacturer claims that the lifespans of the tires are normally distributed with a mean of 40,000 miles and a standard deviation of 4,000 miles. So you test 16 tires and you get the following lifespan. Complete parts A through C below. So first thing we do, we need to draw a frequency distribution table using 5 classes. So let's do that. All right, so I'm going to open this in Excel so we can do this a little bit quicker. All right, so let's open this. All right, so I have my data in Excel. Let's organize this a little bit better. We're going to go to data. We're going to sort this from high to low. So I see my lowest point is 24, 135, and my highest is 48, 84. So let's find my class width. So I'm going to take this and say, let's find the class width. All right, so we're going to set this equal to, it's going to be 16 minus 1. And we need to divide that by, I think it's 75 classes. And so my class width is 49,049.8. Okay. So let's make a distribution table. And so I need 5 classes. My first one starts at 24,135. And I'm going to keep adding class width. Oh, it's still not working, so let's keep doing it manually. Okay, those are my classes. All right, so this will be, okay, my computer wants to do what it wants to do. All right, so let's go ahead and see how many falls in this class. Uh, so I need to go from 24,135 to 29. So it's 1, 2. My first one should be 2 for my frequency. My second one should be from stop at 34. 1, 2, 3. So that's 3. Let's see, can we figure out what this is just by looking at that 2 and 3? Yeah, so it's going to be that first one. So my first class has a frequency of 2. My second class has a frequency of 3. And so you just keep going from there. All right, so the answer, correct answer is B. All right, and so you can do this inside your calculator. You just go in and type this in your calculator, and you hit. You can sort inside your L1, find your lowest and the highest, and subtract it and divide by 5 because we need 5 classes, and you can classify based on that. Okay. So looking at this graph, we see it's symmetrical. And so since it's symmetrical, it's going to make a bell shape. It's going to be symmetrical. It's going to make a normal distribution curve. So that correct answer is B. Good job on that. And so if I wanted to find the mean, it's pretty much just the average. You can also do this in a calculator. So if I just type this data inside of my calculator, uh, we can compute the mean easily just by hitting. So you type this into L1, and you hit go to stat, and you go over to calculate, and you want to click 1 for the first variance statistics. So if you click 1, you see that you get the mean. The X bar is going to be 36,341. So good job with that. And it also tell you your standard deviation. You'll see this, the standard deviation as well. So you can do this all in the calculator. Okay. And so now you just use this data to answer part C. Part C says compare the mean and standard deviation of your sample uh, according to the manufacturer's claim. And the correct answer is C because uh, the sample mean is less than what he claimed. He claimed it was 4,000. We got 36,000 for us. He got 40,000 for the mean, and we got 36,000. All right. And also, he computed 4,000 for the standard deviation, and we have 65,000 for our standard deviation. Well, 6,500, not 65,000. And we'll work problem number 11 the exact same way. So let's try this one. Okay. So I'm gonna open this in the cell. All right, let's sort. Go to data and sort this. And so my highest value is 63. So my class width is gonna be 63 minus 22. All right, we get 41. Let's see how many classes I need. I need to use 7 classes. So I just take this and divide by 7. All right, so my class width is going to be 6. So 6 is my class width. All right, so my first class is going to be 22. Then I'm going to add 6 to it. Then I'm going to add 6 to that. All right, just keep adding 6. Okay, that didn't work. I gotta figure out how to do that again. I haven't done it in a while. Okay, this should be enough to get us started. 1, 2, 3, 4. All right, so this is going to be my first class. It starts at 22, stops at 27. Let's count, let's tally how many fall there. We got 1, 2, so that first one should be 2. Then from 28 to 33, so 1, 2, 3. So we get 3 for the second one. Then from 34 to 39, 1, 2, 3, 4, 5, 6. So that should be enough. My first 3 frequencies should be 2, 3, and 6. So let's go back and look. 2, 3, and 6. Correct answer is D. 2, 3, and 6. Okay. So this is symmetric. So it's gonna give me a bell shape. Okay. And let's find the average or the mean. I would just type this data once again into the calculator and see can we find the mean. Let me see, do I remember how to do this in Excel? So I'll just take this, add it up. Oops. Let's just find the song. So my sum is, all right, so my mean is going to be equal to this divided by 30. So we get 41.73. So 41.7. Okay. It's around 1 decimal place. Standard deviation. You can do this in the calculator as well. Uh, so just type your data into your L1 column, then hit second stats, or just hit stat and go over to calculate. But yeah, and hit number one for the first variance statistics. And you can scroll down and it'll show you your standard deviation. Okay. And then you just answer the question based on what we found. Okay. Z-score. So remember, there's a formula for a Z-score. Uh, and so let's remember that my Z-score formula, let me write it down for you. So to find my Z-score, Z is equal to, it's going to be X minus your mean over your standard deviation. So it's going to be X minus my mean over my standard deviation. So if I want to find my Z-score for 1910, I'm going to take 1910 is going to be my X. So Z is going to be equal to 1910 minus my mean. My mean is 1505. My standard deviation is 310. Okay, let's say it's round to 2 decimal places. Let me type this in. Okay, it's going to get, if I round to 2 decimal places, I get 1.31. Okay. And I think you do this for each value. So it's going to ask me for my z-score for 1250. Just do the same thing. Z is going to be 1250 minus my mean, 1505, divided by my standard deviation, 310. You just do this for each value. Your x changes. So this is x first, this is x second, third, and fourth. Okay. So moving down to number 16. Okay, so this is just finding the area. All right, so to find the area of this rectangle, you want to show the probability by finding the area. All right. All right, so great job at finding the formula. So I'm just saying this distance here times this distance here. And so the distance, my vertical distance on my y-axis is going to be 1 over b minus a. So that's my vertical distance. I'm going to multiply that by b minus a to find my horizontal distance. All right, the difference between here is going to give me the length right here. And so great job at finding that area. This is how you'll find the area. Okay. All right. Show that the value of the function can never be negative. Choose the correct explanation. All right. So the correct explanation is because the denominator of the probability density. So I mean, we know that we're looking for probability. The probability must be equal to 1. The probability can never be negative. Okay. And so we know it's going to be positive because b minus a is going to be that positive version because b is greater than a every time. B must be greater than a because b falls further on the right side. Okay. So I think number 17 works. Yes, number 17 uses this idea. Uh, so we're going to use this formula to find the area. So think about that, why it's going to be 1 over b minus a. and this is going to be AB. Okay, so think about this. The uniform distribution from A equal to 5 to B equals to 25. A says find the probability that X lies between 9 and 20. So basically, I'm going to use my definition we just did in the previous problem. Uh, and so we see my height is, or my length is 1 over B minus A. My width is, it's going to be that whoever this is C and D. I'm looking for this red area. And so we're gonna let it says X lies between 9 and 20. And so we're gonna let C be 9 and D be 20. And let's figure out what we got. Okay. Ah, excuse me. All right, so we're gonna so think about this. This is my length times width. Okay. And so we need to find the area or the probability. We're gonna so we see A is 5, B is 20. We're gonna let C be 9 and D be I'm sorry, B is 25 and D is 20. All right, and so if I want to do my length time my length is gonna be there 1 over B minus 8, which is 1 over 25 minus 5, 1 over 20. My width is going to be the distance between C and D, so it's going to be D minus C, which is 20 minus 9, which is 11. And so my area is going to be my length times my width, which is 11 times 1 over 20, which is, what's that, 11 over 20? What's that, 55? So 0.55. Okay, and so my probability that X lies between 9 and 20 is going to be 55, 55% of 0.55. And I'll do the same thing each time. I just change up my C and D. So next time we're gonna let C be 6 and D be 20. And then my D minus C will be 20 minus 6, which is 14. And so now I have 14 times 11 over 20 times 1 over 20. Sorry. And we get 14 out of 20. Toss that to calculator to get your percentage. 14 out of 20 is going to give me 70% or 0.7. And that's my probability, 0.7. You just continue on down.